to the fourth lecture of this series. So today, we have discussed about the string in the morning, and now we will discuss about the Python module, and we will implement a very simple module, okay, and see how we can use it both from the notebook as well as from the terminal. And I think it is more important to be able to understand how it is used from the terminal, because there are some limitation on the notebook, okay, not exactly limitation, but we'll see what it is. And then we will discuss very briefly what object orientation is, and try to implement the same module in an object oriented way, okay. And I hope that will give us an impression of how the so-called procedural and object oriented ways work. If you remember that we have already discussed in some detail the functional programming yesterday, and we said that Python supports all the major programming paradigms like the normal procedural way, object oriented way, functional way, and things like that. And as I said, mostly we are talking about the discussing about imperative programming here, where you build your logic, you just go ahead and implement everything that. And then I said that the other one, the symbolic programming, we will wait until the machine learning courses start, when you will understand how it works. I also gave one example for the root data frame yesterday, where you saw how we do symbolic or declarative programming. Okay, so first of all, okay, I always forget to check my chat box from time to time. Okay, so now I'll try to check. I missed in the morning some of the discussion. So what is a module? Okay, so module in Python is a very simple concept. If you put a few lines of Python code in a file, give it a name, just .py by convention, but of course it has to be .py when, so in order for it to be a module, it becomes a module. Okay, now if it's a module, and if you have put something useful, you may try to use it in a different program of yours or somebody else's. Okay, and then what you will do, in order to import all the symbols or selectively some symbols, okay, from that module, that means that file, you have to say import and name of the file without the py extension, which becomes the module name, import module. Or as we saw on the very first day, that you can, for example, math is a module, okay, and you can import, just say import math, which will import only the math name, okay, but not all the symbols there. But if you say from math import star, then from the math module it will import everything. If you say from math import log, then it will only import from the math module one symbol, which is log, or pi if you write pi. If you import many symbols, you can separate them by comma, and Python will only import those symbols. Okay, and I also say that there are ways to shorten the name. If you have a very long module name, you can give it a short name. Okay, so these are the way you put your Python code in a module. A package, now we just extended. A package is a collection of modules with a common purpose. That means if I, for example, if I want to do analysis, I may have many modules to do my analysis. So I will create a folder called analysis and put all those Python files, which now I call modules, in that folder. So my analysis folder is now my analysis package, and within that package I have many modules. Okay, and I may have sub packages and so on. In that case, I have a hierarchy. A project is a bigger one. It may have more than analysis. It may have some monitoring. It may have some statistics, it may have some other stuff. Okay, so there could be many such packages which all together will give me a project. So this concept is very generic. It applies to almost any language, and the language should support this structure. And finally, all these things are part of a namespace. I told you that namespace is a more generic name and more acceptable name for such things. So we say that a Python namespace is a combination of modules and packages. Okay. So if you have a package called A, within that you have a module called B, then A dot B actually, with A dot B, you access the module from that package. And if you have some symbol within that package, let's say C, then you can say uh, from A dot B import C, something like this. So it's a very generic structure. Okay? So this is how the modules and packages and project namespace all defined in the context of Python. Now let us define our own module. Okay, so let us try to model a very simple bank account. Okay, how do you do that? Okay, say bank account, for the time being, for simplicity, we will not do a lot of stuff. We'll simply want to check the balance. We will deposit some money and we'll withdraw some money. When we deposit some money, that balance should be updated. When we withdraw some money, the balance should still be updated. Okay, nothing else. And then I can check the balance. So to do that, I say that I check the balance. So there must be a variable, which holds the balance. So it could easily be something like an integer, okay? Let's say, or a floating point number. Let us call it an integer because we will mostly operate with the integer. Now, if it is a simple integer, I think you the storage part, that how you save across once you create the account, how you save across a deposit and a withdraw, will have some problem unless you can actually hold that integer inside, hold that integer somewhere. So a better option will be to use a dictionary, okay, with a key and a value. So that's what we did. We have a function, no more because it's a very open function, because it's a procedural part. This function, I call it an account, okay, and inside that account, all I do is I create a dictionary and I return the dictionary to you. Okay, so then I'll go to the I'll go to the notebook soon. So this is the first thing. In order to create an account, all I will do is take a dictionary, a simple dictionary with one key right now, and of course one value. In future, if you want to expand this account, you may have to use more keys. Then in the same dictionary, I will add more keys. That means corresponding values and so on. So this will still be expandable and scalable in some sense, which we don't foresee right now because it's just a demonstration. So we will, let us assume, and if you don't have any other let's say alternative suggestion, there could be others also, but I think the a dictionary is the best one right now. We'll go with the dictionary. So let us go to our Python. uh, so it's already there. So what I do is here I define slightly differently. I also pass an amount variable. That means when I create the account, I may already pass some value. By default, it is 0. So my dictionary will return me the dictionary the account function returns will also have the amount. If you don't specify it, it will be 0. Okay, so I can, then you have deposit and you have withdraw. They are absolutely simple things to do. If you deposit some money, your account balance will increase. So this is how you do it. You look at the dictionary and you know how to access the dictionary. you just take the name of the dictionary and you pass, instead of an index, in case of list, you pass the key. So this is what you do. You have only one key here, account of account, and you pass the key which is called balance. Then that will give you the value which was initially 0 to start with if you did not pass anything, and then you just add them up. So it's added. Okay. Once again, here, because of the because of the fact that Python work with a reference and not with value, it actually, the incremented value actually is saved in the dictionary. It is not lost. Okay. Similarly, if you withdraw, then you reduce the amount. Of course, as you can see, I have not this bank account is so so open that you can put all everybody can put all the money that they want into the as a deposit. There is no check, no caution, etc. Similarly, when you withdraw, you can also withdraw much more than the amount which is much more than what you already you have in the bank account. It will not actually, it will not complain, and it will be negative. The balance will be negative. So all these things in a realistic case, you have to take care so that you can create the account. There will be some check, and when you withdraw and when you deposit, there will also be some more checks, so that it disallow, I mean, it prevents you from doing unlegal operation. Okay. that apart that apart, now you can create the account. To create the account, you are simply calling this first function, a equals to account. This so it will return a dictionary. So let us look at it. I'll delete first few things. Okay. So this, because I assume that we understand this, I execute, and then I create this account. Okay. And then I insert a cell, and I see print type of a. Okay. And you see that it's a dictionary because you have returned a dictionary. Now, I still want to be a good citizen. That means I want to deposit and withdraw. I want to use the function called deposit and withdraw. Okay. So what I will do is I can remove this for the time being, and I can say deposit a, then some 10,000 rupees. Okay. Then I can do, sorry, deposit a. Okay. And you see that when you deposit something, what I do is I increment the balance. I increase the balance because I'm depositing, and then I am returning the balance itself, the value itself. That's why when you deposit, you get back the value. You don't even have to print, because the notebook automatically prints it. Then as the next one, I can withdraw. I can withdraw. Again, I have to pass the dictionary, because the dictionary is the one which gets updated, the value of that key. And let us say I withdraw 999. So then I have only 1 rupee left in my account. So all these things work as expected. But of course, on a Python notebook, you don't get the flavor about how to, because this is somebody else's module. That means you have developed the module and you are giving me the module so that I can use it. But here, because there is no way that I can understand how it is working. So what I have to do is I have to really go to the terminal and again have this file, and then see how I can use somebody else's module. Okay, so let me go there. So I already have that bank account code, I suppose. Yeah. Okay. So create an account. So there are a few more things. So the first thing is def account, where I return. You can add amount, or you can keep the initial balance to be 0. Either way is fine. Okay. And then you deposit and you withdraw, and you can also from time to time ask for the balance. Okay, you just ask for the balance. Okay, so then you will see some magical line. So you have a file. You have a file. You have a file where I have put all these lines. Now comes the real discussion part. So a Python module is a very simple file where I have put the code. But it is Python developers from the very beginning when Python was created, they wanted to also make sure that the example code, so that the user can easily use it, is also shipped with the module itself. So this is the first statement, that you don't only write the module, you also ship the example code right with the module itself. Then what happens, sometimes you change your module, the module is developed further, and if the two are different, two are separated, that means you have the module, and in a different file you have the example code. Sometimes they may go out of sync. That means the module is developed, but the example code is not corrected in order to reflect the new development. So then I give you two separate things, and you complain that the example doesn't work. But if you can put both the module code and the example code in the same place, then you yourself will always test before shipping it to somebody else. Okay, but it is not really absolutely easy to do that. So Python plays a trick, which I don't know whether you already know it. So this is what I'm doing now. So I will separate again this one into two steps. So first of all, let me let me copy this. So I call it module. No, sorry, not module. Okay, that's fine. Bank account and bank account test. So move bank account test. Okay. Then what I'm going to do is, from the bank account code, I will first delete everything. I'll just keep the bare minimum stuff, which we already discussed about. So this is my module. Okay, this is my module. I can now start Python. I can now start Python. And I want to import the module, like math. I will now say import bank account, and you see that I can import it. So if I say my import bank account, I can now also say deed of bank account. You saw that for anything that you do, you can actually look at the symbols which are inside that account, and you see that there are some special things which belong to which are part of all the modules. Plus there are a few which I have added in my module, which is an account, then balance, then deposit, and then withdraw. These are the four functions, and I don't have any member variable. I only have some functions because this is a procedural part. Okay, so I know that I can create the account, I can have, check the balance, I can deposit, I can withdraw. So then as we did on the notebook, I can do account, not like that. I have to do bank account dot account, because that is the module name, and I can say okay. So what I will do now, import from bank account, import, let's say, account, deposit, withdraw, and balance, all of them, all four of them. And then I don't have to really do specify fully. I can say deposit 1000. Okay, deposit a 1000, and I can also do withdraw 1000. So I don't have any money left in my bank. I can also ask for the balance if you want. Okay, so these are very simple, very boring, and so on. But now it is not that I will always interactively run it. Okay, sometimes I will also run it from my Python program. Okay, from my Python program. So then I can write some Python program. I just copy whatever I did here. I copy in a test program, test.py. I will just add all of them and I can run it. It will also work. Now, the question is, the question is, if somebody gives me this code, which is the module that the developer usually gives us. They give the module code and the testing code. Then it is, so let us say I don't have this, and let us say I don't have this. Instead, I have something like this. So the developer gave me the module code. The developer gave me the module code, and it also gave me some test code by saying that this is test code. Okay. If this is my code, if this is my code, and you will see the following. Python import. Now you will import bank account test. Okay, and you see that something has already happened. That means as soon as you imported the module, okay, then all the code has been executed, which I don't want. I want to just import the module, because this balance means if you go back, you will see that this balance is printed, because when I loaded the code, it has already loaded the symbols, but not only, it has also executed all these lines, and finally it executed this line. So the important point is that if I have two files, one file where I have the module, another file where I have the main code, then these two things can go out of sync. So in principle, these two should always remain at the same place in the same file. But if they are in the same file, then whenever I import the module, also the test code will be automatically executed, which I don't want. So Python does the following. Python will use a trick, which is this one. Python will put the test code under an if statement. Okay, and this if statement is what we'll discuss now. You see that there is a magical if statement. If underscore underscore name is equals to within quote underscore underscore main, then only it will execute this. If this condition is not satisfied, it will not execute these lines. So that means when I import the module, I can expect, when I import the module, I can expect that this variable, this condition is not satisfied. So this will not be executed. So let us try that again once more. And I also uncomment this line. So let us say I'll now again go to Python. I'll again go to Python, and I will again import the module and see what happens. Whether now it is, so you see that now it is not executed because of the if statement that I have implemented. And the module name is bank account test. Okay, sorry, let's go back and put some more reliable thing. So module name is underscore name. So I'll not put module here. So underscore name. What is the value of the underscore name? Because that is what I am using here. So print underscore name. I can once again do it. Maybe it's a little bit confusing. And you see that now the name is bank underscore test. That means it is the name of the module. So when you are in an interactive prompt, you are importing a module. A module also has the test code, which is covered with an if statement, actually that test code is never executed, because the underscore underscore name is never doesn't have a value which is equal to main. Okay, it has a value which is equal to name of the module. Now I quit and I directly execute the whole thing, because this is how you also execute Python. Okay, with the Python interpreter, like we did earlier also. And let us see what happens now. We will see that now the variable name which we put as the first line of the code has a value which is underscore underscore main. Okay, and that is why the part which is covered with the if statement is executed. So now if I give you this module with the module code and the test code, you can always run the test code just with the with Python. Okay, but when you will use my code in your code, you will import that in your own code, but then the underscore underscore name will not be defined as underscore underscore main, and it will never execute the test code. So this is a tricky part, but this is something that you want to understand. Okay, so I'll stop here with the Python module. Let us go to object oriented programming. So object oriented programming is something I'll not go into much detail because it's a huge subject, where you try to develop your software in a data centric way. Okay, you saw that in the bank account module which we have developed, it is really not based on a data centric way. That means your data, I have not shown it, but your data is not hidden anywhere. When you create an account, it actually returns you the dictionary itself, which holds your data. So you don't have to really call the next time. You don't have to really call the call deposit or withdraw. So for example, if you still miss it, for example, I have this account a equals to something, I have deposited and I have withdrawn, but then I can also say I add another one below. I can also say, because I already have the of the dictionary, I could say a balance equals to, okay, I could do that. For that, I don't need to deposit anything. Okay, I could directly do that. So that way, actually, you are breaching the whole safety net. That means, although I tell you that you can do it in a very nice way, but because I give you directly the data which should have been hidden from you, you can just play with it. Now you can call another, for example, some function. You can say withdraw a 100 rupees. Okay, and then you will see that you still have a lot of money. Okay, so it doesn't really mean anything. With Python, it's a so-called bad thing that Python cannot hide the data from you. It exposes the data to you, and it's up to you to work properly. So this is one way, because but in the object oriented strategy, you would not really return me, you would never return me the data directly. Instead, you will return a handle which is sort of which can access the data. And in Python, again, because there is no data hiding, you can also directly access the data, but at least there is another indirection. You don't Python doesn't return the data directly to you. So how do you implement, again, I don't have a lot of time, how do you implement a class for the bank account? Because class, you understand, class is the blueprint for objects. For example, the canonical example is that if you have a plant where you build cars, then you have to design the car. Okay, so after you have the design, you have a blueprint for a certain brand, certain model, and with that same blueprint, you can create n number of cars. Okay, all of them will have very similar properties, maybe slight difference, but you can then change the property of individual cars even if they are built from the same blueprint. So the blueprint is my class, and the instances from the blueprint, that means the vehicles, they are the objects. So this is the object orientation for you. So in the case of bank account also, I will now create a class first. I call it a bank account. Okay, and in Python, as in other languages also, you have two very special functions which you have to implement. One is called the constructor, another is called the destructor. So constructor is the one where Python allows you to create the object correctly. Okay, without the constructor, you may not be able to create the object correctly. So the constructor is indicated by a very special function which is called underscore underscore init underscore underscore. Once again, as you can see, this is a very special function. Okay, so but this function, although this is special function, the arguments are up to you. That means you will add, there is no fixed number of arguments or predefined number of arguments. It will allow you to use as many arguments as you want to do. If you want to delete, if you want to delete your object by yourselves, which in Python we usually don't do, but maybe you sometime you need it, then like I underscore underscore init underscore underscore, you have something called underscore underscore del underscore underscore. This is called the destructor. If this is the constructor, this is the destructor. Okay, and in Python it is not used much. In C++ or other places where you explicitly allocate memory, then there the destructors are more important. And then as usual, you have like the withdraw, you have deposit. If you wanted, you also have you could use the balance, etc., etc. So I have two things which are magical. You will see that there is a parameter, not the parameter, a symbol which is called self. Okay, so this is very important and it's almost impossible to explain properly. You will get used to it. So in Python, you will see that inside the definition of a class, the first parameter of all the functions, all the methods now I'll call, which belong to an object, will have self as the first parameter. Okay, so when you have an object, self is a reference to the object itself. Once again, I will not be able to discuss it fully, but I have a slide for that. I can show you the slide. We can discuss also, but it's not absolutely easy. Okay, so the self parameter is the first argument of every class instance method. Okay, so that means that is object method, including init and del, is an explicit reference to the current instance of the class. That means instance of the class means the object itself. Okay, so by convention, this argument is always called self, but it is not a keyword. That means you can give any name if you want it. So self, when you are when you are calling the underscore underscore init underscore underscore underscore, that means when you are creating the object. So how do you create an object? Let us go to that. So once you have this, if you have this class definition, you can create an object like this. So bank account is the name of the class, and you pass 100 or 1000, whatever, because there is also a second argument with default value. So you can say a equals to bank account. So now you see that a is no more a dictionary, because here I have not used any dictionary anywhere. I have actually used a dictionary like thing, but not an explicit dictionary. So if I execute it, if I execute this one, okay, and you see that the constructor is printed, because in the underscore underscore init, I am printing that, and it tells you that when you create the object, actually this function is called. Okay, now what I'll do is I will print the type of this type of a, and I'll see that it's not a dictionary, but it's actually a class, and this class is called a bank account. Okay, this is the name of the class, and because we have not defined any namespace, this class comes from the main namespace, the namespace which is in the notebook as the main. So this is how you create the object. Okay, and then Now that you have created an object, you can look at all the attributes of the object, which is A, and you just type deed of A, and you see that there are lots of attributes. Okay, and the two attributes which you have added are withdraw and deposit, and all others are default attributes which come for any object. And two of them you now know. One is the underscore underscore init, and the other one is underscore underscore del. Okay, and there are more. Okay, there are more. So now you have deposited it. You can also how do you now you started with a bank account. Now how will you deposit some money, or how will you withdraw some money? In the case of our original module, we called a function called deposit, and then we passed the dictionary, which is A, and we put in amount that we want to deposit or we want to withdraw. But now in the object oriented case, the object actually takes precedence. That means when you now want to call deposit or withdraw, actually that will be a property or attribute of the object itself. That's what we have seen. We have seen that if I look at the deed of A is my object, which I have checked just now, that it is an object of class bank account, and it has got two properties, deposit and withdraw. So if I want to now deposit and withdraw, I have to use the object notation. I don't say withdraw a 10. I will say A, because A is my object, A dot withdraw or A dot deposit. And I will have this A dot withdraw 100. Now this is almost, of course, equivalent to this one. This is equivalent to this one. So A 100 in the other case. So this also tells you that whatever you do on the left hand side, actually Python will translate it into a procedural part where it will pass A as the first argument, of the deposit function. And that is why the first argument of all the methods have the object itself as the parameter, because this is how it is unfolded. Although you are calling this, actually Python is calling this. So it will just pass, it will take the object and pass the object reference as the first argument of a deposit function instead of a deposit, oh sorry, not deposit here, withdraw. Okay, withdraw, because I'm calling withdraw here. So if you execute a dot withdraw, as if you are calling from somewhere, some namespace, the withdraw function, and passing the object as the first argument. And that is why the first argument inside the class definition of all the methods which pertain to an object is self. So I hope this is what is written here. If you really read about it, this is what is written here. I hope you understand. You have followed it. I'll just check whether there are any. No, there are nothing. Okay. So still, you have to get used to it, because as I said, it's not absolutely easy to get hold of the fact that why everywhere I have self as the first argument. So this is one of the explanations for which may or may not be a very real scenario in Python, but most likely when we discuss about explain why the first argument is always self, which is a reference to the object itself, which I am dealing with, that can be explained by saying that if I do an object oriented, I call an object oriented method through the object, actually Python may, because Python is written in C, and C doesn't have this object orientation per se. So when you go to C, actually you are doing a procedural part. Okay, so and this one, as we have already discussed, is a procedural part, and in that procedure what you will do is you will take the object itself, its pointer in the C world, and you will pass as the first argument the pointer of that object. Okay, so okay, now the difference between A and bank account is that the bank account is a class, which is the blueprint, and A is the object, which is the instance of from that blueprint. So you can, if you do a deed of, so we have seen the deed of A. If we also want to check the deed of bank account, you will see that there are something which here it is absolutely the same, but maybe in some other cases it might be slightly different, which we'll check later on. Now, if you want to del, I say that I don't want to del. Usually, we don't need to delete an object, but if you want, you can do that. So, if you explicitly delete an object, you will see in our case that this line will be executed, that the destructor was called. Now, if I do that, what happens? Can I look at it again? Can I look at it again? And you see that now the object A is not there anymore. Okay, A is not defined. So this is a very interesting one. If you really, if you really want to take charge of your memory, and you are creating some very heavy load objects, heavy memory objects in the memory, in your memory space, and you want to delete them by yourself manually, you can do it also from time to time if this is properly created by executing del on the object. So it will just remove it. If you don't do it, of course, and if you don't use it, the garbage collector do the similar thing at some other point. Okay, so now A is again gone. So I have to create it again. Now once again, let us look at this. Okay, so I still don't I still have more things to check. That you have self as the first argument everywhere. In the case of del, because it doesn't do anything, self is not used, but in all other cases self is used. So the first one, when I create the object, I use the self. So self, I told you the self is the object itself, and to that object I attach a variable. I call it underscore underscore balance. And I told you that Python works by convention. If I put underscore underscore in the beginning, I am giving you a hint that this is a private variable. Please don't access that variable directly. Okay, so this is the hint. If I generally don't do underscore underscore the name of the variable underscore underscore, because that is reserved by Python itself. Okay, so that is a very special either variable or function, but I can always just give a hint to the client code, to the user, that if I do underscore underscore, then it's a private variable. So this one is a private variable. This one is a private variable, but this one is actually a part of the object. That's why it's called object, which is self here, dot underscore underscore balance. This doesn't mean that Python cannot breach it. So I will show you that Python can breach it. So let us create the object once again. So not here. I have deleted it. So I will create it again. I will create it again. I delete it. This one. This also I can create. I can delete. So let us create it again. Okay. So I have created the object. I have created the object. Now, in principle, I should either deposit or withdraw money in order to operate on the object. But I don't, it's like I want to hack the code, because Python allows me to hack the code. So what I will do is I will access the underscore underscore balance variable directly. How do I access the balance variable? Because I saw that in the code it is self dot something, and self is the object itself. So what I can do is I can directly put all the balance to 0 just by doing this. I don't have to really do anything. So this is a valid statement in Python. It's a valid statement in Python. And now if I want to withdraw it, let us see what happens. Okay. So I have put the account 100. No. The constructor is called, sorry, this is not, you see that there is another bug, and it also works. This is another very high level feature of Python. In Python, unlike C++, you can also, this is by mistake that I realized, that instead of underscore balance, I have put only one underscore. And that variable, one underscore is nowhere. Okay. Okay, so you see that there is only, just a moment, somewhere else. Okay, so you see that I have only one underscore balance, and one underscore balance is nowhere in my class. But Python doesn't tell me that the underscore balance variable is not found. Temporarily, it adds this variable to the object. So this is a very high level feature of Python, that dynamically, after you have created the class, after you have created the object, you can also add new attributes to the object, and you can even save from one let's say session to the other the new attributes. But that is not, let's say, in most cases an advisable thing to do, but at least it doesn't give you an error. You can make a mistake. But if I put two underscores now, that means I am really accessing the variable which is here. Okay, so this one with two underscores. So now I am actually making the balance 0. And if I do this, withdraw, why it still doesn't work? What is happening? Something is wrong here. I don't understand, but I always thought that it should work. But it is not working. It is, if I withdraw, I always get, so the balance is always the same. Let me just check once more. It's wrong here. Deposit, and let me do def balance self return self dot balance. Okay, so self balance equals to amount, structure balance, reposit, and so on. So I start once more, then I create once again. This is where the whole thing actually goes wrong. This is where the whole thing goes wrong. Okay, I have to come back to that because something is going wrong here. You see that when I create, and I'm pretty sure it's the problem with the notebook, not with the code. I can actually take this code. I can actually take this code, and I can say bank account account.py. Okay, this one, and I can do Python import bank account. Okay, then I can create an account, bank account. I said 1000. So the constructor is called, and then I can say a dot withdraw something 100, then it will be something like 900. And if I now say a underscore balance equals to 0, and I withdraw again, it still works. So something. So let me, maybe Python has done something which so let me not put, maybe Python has already hidden. If I put underscore underscore with the new version, Python 3, maybe Python has done the right job. So let us remove the underscore underscore from balance, okay, and let us execute it again. I create the object, and then I just and see what happens. Okay, so it's very difficult. Dot withdraw. You see that now it works. So Python has done something good with, maybe I forgot. I put the underscore underscore. So as I said, it's not only by hint, and Python doesn't tell you, it doesn't have a very correct implementation that when you access a variable which is hidden in which is supposed to be private, because I have put underscore underscore there. Okay, Python should have uh, prevented me from even accessing that variable, but it did not do that. But on the other hand, it simply ignored my execution. So although I tried to reset to 0, dot underscore underscore balance equals to 0, it simply ignored that statement. So the original value continued to be valid. But if I remove the underscore underscore, you see that Python actually does what I thought, at least from Python 2 I had in my mind, that you can access the variable directly. And so earlier in Python 2, I think it was just a hint that you have to put underscore underscore in order to tell that it is a private variable. Now with Python 3, it doesn't do a very good job. That means it allows me to access private variable which is supposed to be private. But if you put underscore underscore, it doesn't tell me that you cannot access that variable, but it also ignores the execution and keeps the original value. So this is something also I learned now. Okay, so sorry, it took some time for understanding. Is it clear, or I think are you totally confused? Can somebody assure that you're following it?
Sir, Python is written in C, so how is it like data hiding is there? So
No, there is no data hiding per se, but Python is written in C doesn't mean that you cannot do, because Python also has its own grammar. Okay, it has its own interpreter, some parsing and so on. So from that point of view, also Python can prevent you from accessing some variable, okay, which is defined with, for example, here if you put underscore underscore, we can also see whether if I put only one underscore, the same thing happens. This is your exercise. Instead of two underscores, by convention I put two underscores. So you saw now something which also I learned, that if you put two underscores before the name of the variable, which is a member variable because it's within the object, okay, then Python, when you access them as a client code from outside the class, Python doesn't tell you that no, this variable is not defined, this is a private variable, you cannot access it. It allows you to access, but it doesn't do anything. That means if you want to reset that variable, it doesn't do anything, silently discards that statement. So for example, let us again, so I have already gone to this. Okay, now I think this one will be, the notebook will be even more clumsy. Then I have 100 as balance. Let me print it and see what happens. I know that I cannot reset it, but, and you see that bank account Why? Balance, 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 balance. Okay, so it was working. Now it's a bank account object has no attribute underscore underscore balance. So now it is a again another thing. Okay, so either this is totally screwed up. So I will go back to my this one. So everything should be there. So import from bank account, import bank account. Okay, bank from bank account, import bank account. Then I say A equals to bank account 1000 or whatever. Then I am now printing A dot underscore underscore balance. If it tells me that you cannot access it, then I'm happy. Then Python is doing something balance. Bank account object has no attribute underscore underscore balance. Still, it doesn't tell me the correct thing because I know that I have a variable called underscore underscore balance, which is part of it. So I am accessing it through the object. So in principle, it should give me the correct thing, but it is saying that no, you cannot access it. That variable is not defined. So that this means I am not fully updated. Python is doing a better job now. Python is doing. If you want to access, and on the other hand, now if I remove it, if I remove all the underscores, then let's see what happens now that we are discovering something. Okay, so Python from bank account, you create this and you say print a dot. Oh, sorry, it's I have to change. I have to say get balance because otherwise, no, it's okay. Balance is just a function. Okay, so A is my object. I can look at the type of the object called A. A is my bank account object. So I can now say print A dot balance. And you see that I can directly access the balance variable through the object. I can also do, that is very interesting. And this one, this object is not callable because by mistake I also have a balance method, so which is not, so I should not have done that. I will do get balance here, get balance. Let us see. Okay, so I can do get balance. This should now work. This works. And if I simply check access the variable directly, the balance variable directly, this also works. So this is the old stuff. If you don't put the underscore, you can access the private, so-called private variables also, which you should not have accessed. But now with the new Python, although it is not, I mean, the error messages are not very clear. Okay, it should have said that. Uh, I mean, a more I mean clearer message. But if you put underscore underscore, Python really hides that variable from you, and you are not able to access that. If you want to set it, a dot underscore underscore balance, then you are as if creating a new variable which has nothing to do with the variable which is there in the class object. That's why when you set it, when we were doing a dot underscore underscore balance equals to 0, Python was not telling me anything. Python was not telling me anything because it was creating a new variable with the same kind of name. But that is not the same as the variable which is there, which tells me that Python, when you put underscore underscore, and when you try to access a variable with underscore underscore, Python says that that variable is not anywhere. This means that Python will, so you see that bank account attribute doesn't have anything called balance. That means Python will probably add something to the name which you have given so that it can be it can be made actually anonymous in some way. You can never guess what exactly will be name of the variable. So if you could guess the name of the variable, probably you will be able to access it. I don't know whether I could explain it. Okay, but I don't have much time, so I have to go past that. So what we will do now, okay, self, I think by after all this discussion, you have understood self. You have also understood, hopefully, that in Python now there are better ways, and I think it's there is a name I which I don't remember, and if you read it or tomorrow I will try to find it out. Yes, it is there, that if you put underscore underscore in front of the name of a member variable in a certain class, Python will actually mask that name by adding some other I don't know exactly what, so that you can never find the correct variable name. And if you can never find the correct variable name, you cannot directly access the variable. You have to really access it through the methods. Okay, so this is how, it's not that there is a very strict way of hiding the variable. It will not hide it, it will simply mask it by putting some other arbitrary string in front of the name of the variable which you give, so that you cannot find it easily. But there must be some rule with the help of which you will be able to access it. Okay, so with that, now I have two more things and we can stop. So accessor, we take another example, accessor. Let us talk about another class, okay, which is called track. Let's say music track. So the music track has got artist, it has got a title of the track, and it has got the duration. So what you do now, instead of one, now you have three attributes, and in the constructor, which is my this is my constructor, you say that what I do is self, then I put underscore artist. I could have put two underscores also, by the way. I mean, it will be a good idea to put two underscores, something like this. I have put here one because sometimes I'm not very careful. Okay, if I do that, so you have three properties. So you are saying self dot underscore underscore artist equals to artist, which you assign, the title also you assign, and duration also you assign. So there are three variables. Now, as I said, you are not really able to access this variable anymore. That is masked. This variable has a it will be masked by something else, so that you will never be able to, and these are private variables, able to access it, let us assume. So in order to access, because without accessing also, what can I do? In order to access that, you need some accessor methods. So what are those accessor method? I'll just simply call it artist, and if I call artist, artist will return me the real artist. The title will return this title, duration will return the duration. So if I now create a track, now track has got three parameters except for the self. Okay, so track equals, let's say t equals to track, and you pass three arguments like I did in the other case. Okay, and then you can now, so we can execute it. You can execute this one. You can create a track, you can create a track, and you can look at the artist, and you see that I'm calling a method called artist here. I'm calling a method called artist here. So artist is AA. Now we will develop this one a little bit more. Sometimes because this is a track and you create an object, you also want to check this. You also want to check this, and you see, let us see what happens. I'll just add two more. So I want to convert the object, the whole object, into a string. This is possible. So I pass to the string function, the object itself. The object is my t. Okay, and let's see what happens. Sorry, and you see that there is nothing useful. It only tells me the pointer. It only tells me the pointer where it can be found. So this is nothing meaningful. I can also simply print t here, and you see that it will also do the same thing. Okay? It is not giving me any useful information, but I can do something more now. What I can do, I can actually implement one of the operator overloading, which is called underscore underscore str underscore underscore. So the next example has everything plus this line, So I just implement the underscore underscore str underscore underscore. So if you implement that, let us look at this. So I execute this one. then I execute I create another track, and you see that now I do str of t1, and now it will give me useful information. Instead of the pointer itself, it will give me useful information. So it gives me the total information about the track, because this is what I have implemented. So I have implemented the str. If you can do that, then if you take the object, you see that this is an object, this is an opaque object, and on top of that, if you pass the object to the string function, it actually now gives you useful information. I still want to print T1, only T1, not str of T1, and that should also give me useful information. For that, there is another function, another overloading, which is called representation, REPR, underscore, underscore, REPR. Let us say that I do exactly the same as string. Okay, I can exactly same as string. So if I implement this and I execute, I create another track. Okay, and I simply now pass T2. Okay, and you see that I get the same kind of information. Okay, so these are essentially to give you are the developer, you are developing an object. That means you are writing the class, and you should also implement the underscore underscore str underscore underscore and underscore underscore repr underscore underscore, so that people can simply type, and you know that on the command line or on the notebook, it's very easy to just type like integer. If I put a equals to 5, I just put a there, I return, and it gives me some useful information. So similarly, even for a complex object, I should get useful information just by typing the name of the object, or putting just passing them to a string. So these are the two things that you should always remember when you develop some Python class, Python implements a Python object. So the last one here is that I am not very happy. I am not very happy that I have to call a function. I have to call a function uh, in order to get the name of the artist, then title and the duration, etc., etc. But there is no other way, because now with the two underscores before the name, the variable has a mask now. All the variables have mask now, and you don't know the name of the variables, and you cannot really access those names. Okay, so which is also not actually advisable to directly access them. So what you can do, you can have some syntactic sugar by saying that I want to decorate my methods, artist, title, duration, etc., so that I will actually not call a function. In fact, I will call a function, but in my code, they will look like as if I am directly accessing the attribute. Okay, but now that I don't know the exact name of the attribute, I will call the name of the function as the attribute. That means I'll just remove the brackets. So that in order to do that, you have to simply add some more decoration, and this is called the same class. Okay, and before the artist function, you just put add property. This is a decorator. Add property, etc. Okay, so these are decorators. Very simple, but they are useful. So now you can create another object, the same thing. And you see that instead of putting title and bracket here, this will also work. Okay, I am simply achieving the same thing by putting only the name of the method and not putting the brackets. So this will now work. This will now work. Okay, wow. No, maybe now I have screwed it up, because I have many times I have the track. Many times I have the track class and I have loaded them. So it's still okay. Now it's correct. So sometimes with the notebook, I make a mistake, and you see that now if I check the title, it only tells me the title, and for that I don't have to do that. If I do it now, because it is the object is not. So now if you do the decoration, actually you lose the function. You only the this way. Similarly for the artist. Similarly for the artist. So this is the second thing. Now we will discuss, I have still some 10 minutes, 10, 15 minutes. I will discuss about the uh, inheritance in Python, object orientation. In object orientation, you know that there are many ways of developing your software. One is called inheritance, another is called composition. Okay, and also there are others. Inheritance means some kind of code reuse. That means if you want to develop your object, you will not start developing it from scratch right away, but what you will do is that you will first check whether an object of similar kind already exists. Okay, if there is an object which could be similar to the object you are thinking about, whether you can use that object as a base object, and then you extend that base object by adding a few more properties so that it can be suitable for your purpose. So if you can do that, then it's called inheritance. That means you take the original, you take a base object, which we will also call mother object or parent object, and your object is a derived object from the base object, or you can also call your object as a daughter object. So these, if you have two objects which have mother daughter or base derived hierarchy, then this is called inheritance. For example, animal. So if I have a mammal is an animal. Okay, so mammal as an animal have got some inheritance relationship where the mammal, the animal is the mother, mammal is the daughter. Similarly, from the mammal, you can go to human being. So that will be a daughter of the human will be a daughter of the mammal, and from the human you can also have many different categories. All of, so you can have actually a huge, a long hierarchical path in order to develop one object. It depends on, for example, take an example in a high energy physics. If you are thinking about a root histogram in root, so a root histogram actually has a long hierarchy. Similarly, there could be many objects in Python also. There are many objects with long hierarchy. Long hierarchy is bad because it takes a lot of CPU time in order to create the ultimate object. So if you, for example, if you have mother-daughter relationship in your software, which is 10 hierarchy deep, then in order to, and yours is the last daughter, then in order to create an object of the last daughter, you have to also create all the other 9 mothers. Okay, and after all the 9 mothers are successfully created, only then the last one, which is the last daughter, will be created. So there is a lot of passes, okay, back and forth in order to, so first you try to create your object, so that in turn will try to create its mother and its mother and so on. So it will, the bubble will go up to the first mother. So once the first mother is successfully created, then it will go down to check to make sure that the second one is successfully created, and so on, and then the bubble will come down to the last daughter to successfully create the last daughter. So this is a huge hierarchy, and it actually wastes a lot of time, CPU time. So it's always a good idea to be very careful about the object hierarchy. But there are some framework like root, which is based on this hierarchy, where you have a single mother and from which everything comes. Okay, so that way, although because it's C++, you never feel that this can actually cause you a lot of CPU trouble, but it actually does. Okay, so everybody, all other languages try to make sure that you don't use long hierarchies, but you use some other object oriented method. So you combine inheritance with something called a composition in order to achieve the performance. But in this case, in the case of inheritance, it's not really very difficult. So if I have a class called person and I have a class called student, I know that the student is a daughter class or a derived class of a person, because person is more common. That means it has got less properties. Okay, while student actually can inherit all the properties of a person, and then it can add its own properties, and that is what is happening. For example, in the constructor of a person, we have only two properties. One is called name, one is called age, while in the case of the student, we have both name and age, and on top of that we might also have an ID of a student. So this is the third property. So the person, if I create a person, it can never access the ID property. But if I create a student, well, because it is inheriting from a person, first it will create the person object, then it will have its own property as the ID object, and a student object can always access all the three properties. Okay, so the way, technically the way you say, if you have a person, if you have a person class which doesn't derive from anything, it's a base class, you simply say class person. Okay, of course by default now with the new Python, all the objects are actually inheriting from some mother object called object. So we can skip that also. Python still works. Okay, and when you create, when you develop your student class and you want to specify that the student class is a derived class from person, then what you do is you put the person in the bracket on it in order to indicate to the Python interpreter that it's a derived class derived from the person class. And when you have this is more important, when you uh, implement your constructor, in the constructor of a student there will be three parameters: name, age, and ID. And you simply take the name and age, because this I can pass to the person object, and I create a person with name and age. Because, and then when you create when I call this person name and age, I am actually calling this constructor of the person, which will assign underscore name and underscore age, and by myself I am only assigning the ID, because that is the extra property exclusive to the student. And then there is also another another thing. For example, if I have a method called introduce in the base class, which I have here, and the introduce means you just return a string. Okay, you just greet that person name this and age this. You can also override. That means you if you have if you implement a method in the base class, the that method can be overridden in the daughter or in the derived class. Okay, that is what we have done. So for example, if I now create a person, I'll show you that. And if I create a student, if I call introduce on the person object and introduce on the student object, for the person object it will return you this. For the student object it will return you this, although the name is the same. That means the derived class can override a method which is defined in the base class. So let us do it. Let us create one. Uh, so this one, I hope there is no error. Okay, so we insert two cells below above this. Okay. So I say P equals to person, let's say A and 30. This should work. And I add another one, a student. S equals to student, then B, let's say 20 and 1 2 3 4. This is the ID. This is the third parameter. So this also works. Okay, now I can say because I have not implemented either underscore str underscore underscore or repr underscore before and after. I cannot simply put str of p, str of s, or just p and s. I cannot do that, but I can say p dot introduce, because p is the object, introduce is the method. Introduce. So it will say that person name a, age 30. And if I do happens introduce, okay, now this will not work. I understand, because once again, for simplicity I will because this is again Python 2. For the time being I will remove this and I'll fix this. I have to change the way it works, because with underscore now really the variables have become private. So if you have a private variable in the mother class, even the daughter class cannot access those private variables. This is the true object orientation. So they have to be accessed through accessors, and I have to implement the accessors also there. If I put underscore there, then I have to give accessor, like in the case of track I gave the accessors. I also have to give accessor here, and instead of directly accessing uh, name and age, I have to call those accessor methods. But right now I think with this it should work. Let us see. We introduce. Okay, something is wrong here. So I'm removing all the underscores, okay, for the time being. I should have been careful, but I was not, because I never updated myself fully. So now this should work, and in principle this should also work. This is still not working. Oh, so this is very good. So I think I think I have to really say this: def name self is return. So then I can put underscore, no problem. Underscore return self underscore name, and similarly def age self return self underscore age, and here they are fine. They're fine here. So that means Python is doing a better job in terms of privacy. So there I will simply put name here, because these are public, these are not private, and this is anyway the part of the daughter class itself. So let us see whether this works. So this 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 introduce works, and introduced it doesn't work still. Why? Again I have put somewhere. No, but I'm not doing anywhere underscore name. I'm simply calling the method here. Then I'm lost. Why this one still doesn't work? Introduce self, student name, etc., etc., self name, self age, and self ID. And it says here itself self name, self age. Student object has no attribute self name. This I know, but I'm not using the student object. Okay, I'm a little bit confused now. I think I have to also fix this line again. What used to work for Python 2 probably doesn't work, because what I'm doing is I'm first calling the mother, creating the mother, and then adding properties. So most likely this one is not working correctly, and but this I cannot solve right now. I have to do it. I'll fix the code. I'll share it with you. Okay, so but anyhow the okay, although this is not fully done, the concept should be I think now known to you, that you have a person class, which is the base class. You have a derived class, and from the base class to the derived class, if you do it, then the public properties means here the public properties are simply mean that you are talking about the name, age, and introduce. Okay, of the mother will be inherited by the daughter. If there is a method in the mother, in principle you can also override that method in the daughter. Okay, that is what we have done. But I think what is still wrong is the in the case of inheritance is how you create the person object, which is a superset of the which is the base class of the student object. I will try to come back to that later on. Okay, so this is something which we missed. Operator overloading. Now, operator overloading, I told you that let us try to implement, this is probably the last one. The Let us try to implement an integer object. We know that in Python has a class called int. So the Python integers are int objects. So we can try to implement our own integer object, part of it, not fully. On the internet, you will find better implementation. Here, I just wanted to make sure that something which you do works. Some part will not work, so you have to be very careful. And this is very incomplete. This is absolutely incomplete. Okay, so so I have a class called integer. Okay, then I have a constructor where now self you have understood. So I'm not talking about self. You are actually passing a value when you create the integer. If you don't pass the value, it will be by default 0. Okay, now this line sort of tells me, because v equals to 0 is the default value, that v has an integer type, int type, the normal Python default integer type. Okay, so what I simply do is that I actually save or assign whatever that value v to my private variable underscore value. Then I can now implement the operator overloading, so that if I create my own integer like a, I can add a plus 1. So a is my own integer. On the right hand side, you have 1, which is the Python integer. So as I said, this is incomplete. I implement it in such a way that it works. But in principle, there will be some more typecasting which will be needed for a more complete solution. So I do it. So I define my underscore add in order to add my integer with another integer. And there what happens is that you simply return, because when you do this, self and value, that means self is my own object and value is something which I want to add. So when I say a plus 1, actually this function will be called, the self. From the self you will extract the value. Okay, because self is an object, opaque object, it will extract the value and you will add that value to the value which I am passing, which is in my case 1. Okay, so this is how this will work. So this is self dot value plus value. Similarly, self dot value minus value or multiplication. Plus, for simplicity, I have also implemented the str and the representation functions. Now let us do it. So I can execute it. Okay, so this is executed, and I can execute this also, and I can see that I have created my own integer with a value of 10, initialized it with a value of 10. And if I look at the type of the variable, I see that it's an integer. Now that I have already implemented the str and the representation, I can also print it. I can either say print str of d, which will be 10, or I can, because of the representation, I can simply type d, and this should also tell me whatever I have implemented. Okay, so it is integer 10. Now comes the main part. I can now print d plus 2. I can print d minus 2 or d into 2. I can assign d to, reassign d to 5 and check whether something, I compare with something. So few things. I think there, if you want to do a very good job, you have to implement them correctly. And this implementation, I must say, is something which I took from somewhere. But now I understand that this doesn't work. For example, for division, it doesn't work. For comparison, whether this value is greater than something, doesn't work, because I have to do more work. And there are many such implementation out in the market. Okay, so but this should work. Let us say whether this works. You see that when I do d plus 2, it says calling underscore add, which is written there. Calling underscore add, and it tells me the value, which is 12. So d was 10 and plus 2, 12. Calling sub, it gives me 8. Calling mult, it gives me 20. And when you compare the two, whether d is equals to 5, it says yes. So this is interesting because D is your own object, integer object. Okay, and you are actually comparing your D with a value. Okay, so and Python somehow makes sure that the right hand side and the left hand side of the comparison have similar data type, otherwise it would have failed. Certain, I mean, that's why I had to remove the comparison operator, because that I could not implement very quickly. Okay, but this one works, the equals part works, and it tells me that yes, it's correct. So you can see that your exercise will be, again, it is available in many places. If you do high energy physics, the four vector relativistic Lorentz vector will be very important for you, a four vector. So you can try to implement a three vector in Python or four vector in Python. Once you do that, you will also like to do the operator overloading so that you can use them as natural vectors, either three or four vectors. Okay, so I think I have covered, except for the fact that I still have to, so decorator I have covered. I only have two more things. So in Python, you also have class method and static method. Okay, what is a, so you have a class. For example, I have a class called person, and I have a constructor. So if I have a constructor, that means I am directly creating the object like this. Okay, so this is a person class which you have seen. But I also have a decorator which is called a class method. I have a decorator called class method. I also have another decorator which is called static method. So this means, this two means, this one has nothing to do with any class, any object. You can see that the implementation, you can see that this is actually a very simple function. But because you don't, you do not have another suitable namespace where you want to put that function, you have added them inside the class definition, but it's not a part of the class. If you don't decorate it, it will look like that it will look like that it's a part of the class, and Python will not be able to work because it doesn't have the self as the first argument. That is why this decorator is needed. So although its natural place is not in the inside the person class, but we don't also find a suitable namespace where we can put it. We have put it in inside the person class, but we have decorated that it's a static method. It has nothing to do, it has nothing to do with the object. And I can, it's a public method. I can directly access that method in a namespace way. That means I'll give the name of the class, which is person, dot name of the method, or no, not method, function, and I will pass the argument. Okay, but this one is more interesting. This one is more interesting, that I can actually use a class method also uh, in order to create an object, so that I can change the argument. You see that init, this constructor has a set of arguments, name and age. And this one, I have a totally different name of the method. The name of the method is from birth year. I will still create the person object, because the third one doesn't have to do with anything about creating an object. But the first two will both create a person object. In the first case, you have already learned how to create an object, and we have done that. In the second case, what I am doing is I am using a class method. Okay, and I am using a totally different argument list, and you see that I am passing the name, but I am passing not the age, I am passing a year. And implementation detail is not very important, this detail, but I will still create a person object. So what I'm doing is that here, when I do that, instead I'm saying that it's a class method. That means I will say name of the class, and then dot, I call the function. Again, it's not a method, because it is not attached to an object. It's not attached to an object, so it's a function, and this function can be directly called using the person namespace, the class as the namespace. And in this case, and you see that there are three arguments, but you are passing only two arguments. That means Python will call a bare function called from birth year, and it will take the namespace, which is a person class here, and use it as the first argument, similar to what I showed if you have a self. Okay, so a dot withdraw will be withdraw a comma the value. Similarly, here also, if you have person from birth year student A and 1996, actually Python will call a bare function called from birth year. Then the first argument will be person, and the second one, second and third will remain the same. And that is why we have 3 arguments here. So this is another thing which is used very extensively in any Python software development, object development, because there are many places when you have to club together some static methods inside a class, and then you have to decorate them so that they can work without any problem. And in many cases you will also use class method. This is true for not only for Python, it is also true for C++. If you when you will learn root, or if you already know root, you know that the class methods are used very extensively in C++ also. Okay. And then finally I'll just okay, this I'll stop, because this is so in introspection and reflection I cannot do, because it's again very important, but it also I have some lines, but these are not really complete, because I need to discuss about it. So I tried to explain to you what object orientation is in Python, what generally object orientation is, and how it is done in Python. I have not actually discussed about one strategy which is called a composition. Okay. Or aggregation. So there are three strategies, like inheritance, composition, aggregation. I have not talked about aggregation and composition. I will, in the slides I will put one example. If you look at them, then I hope you will be able to understand. What I failed to explain is in Python 3, which I should have checked myself, how the base class actually initializes the derived class actually first initializes the base class and then adds its own properties. So I'll fix these two. The person, I think, is correct. The student class, this line to me is wrong. Right now I don't have time to check the documentation. So I'll correct it so that it works, and then I'll share the notebook with you. Okay, so if you have questions, then I can try to answer them. Otherwise, tomorrow and day after, I think we will dedicate. Sorry, not day after. The 2 lectures tomorrow will dedicate to NumPy. Then very little bit of pandas. Just I think one example or 2 examples, and some part on the plotting packages like Matplotlib, so that you prepare yourself for the machine learning. Questions? Okay, you can also ask me questions over mail, or even tomorrow if you. And I think if it is I mean, you will need object orientation in Python. Whatever you do, if you do any serious development, you have to develop your own objects. So understanding how it works is I have only touched upon the very elementary part. There are more to it, but not so much more in Python, because Python object orientation is pretty elementary, I would say, but it still works. Okay, so you have to do that. So it's better that you understand, and if you cannot follow something, you can always ask me either over mail or on the chat box, or wherever. Even tomorrow, if you want, I can also try to have some other session, because this is a very tight schedule. I cannot really do much more than this. Okay, but if there are questions, I can try to answer them after these online courses are over. I can take a special session and try to answer all this, because anyway I will give you a set of exercises, and I will expect you to do all those exercises. And if possible, you can send, if you want, you can send me the answer script also, and we can discuss the responses in a separate session, but not in the sex. I mean, these are very, very crowded.
Sir, one question.
Yes.
You gave one example of how we make some module like with .py extension.
Yes.
So
So I
there
can
we
go
saw
here.
that when we are trying that module with Python, then the underscore underscore name is taking the value underscore underscore main.
Yeah.
And when we are importing, that is taking the name of the module. Why
Yes.
is it so? I mean, is there any particular reason or?
No, there is no particular reason. I mean, if you think about it, if you are in a Python prompt, if you type Python, you go into the Python prompt. Okay, so
Hmm,
you know that now you are running your main loop. So the main is already there. Main is occupied.
okay.
No, because in a particular program, because Python is written in C, you should have only
Hmm,
one main program.
hmm.
This you agree.
Just like we
You
use
cannot have,
in C. Hmm,
yeah. So if you type Python like this, and you say print underscore underscore name underscore underscore, and you see that this is your main. So there cannot be any other main. The main is already occupied by the running session.
okay,
Okay.
okay. Hmm,
So now whatever you import, whatever module you import, if you look at the name of those modules, they will be. So if I for example, if I do import, let's say bank account test, bank account, bank account test. If I import that, so your name is now not main, it is bank account test. Also sitting here, you can say bank account test is your the name of the module that you have imported, dot underscore underscore name. Okay, it is also bank account test.
okay.
So you have only one main in your program. Everywhere you have to use only one single main. So if the main is already taken by the loop, that means the Python running Python environment, then the other ones, I mean, whatever module you import, there the name cannot be main. There the name will be only the name of the module. But when you are running through Python like this, okay,
Hmm,
then also it's the same, because you are now running the Python fully. You are not doing any import at all. You are running over the module file. So you are running over the module file, this one.
hmm,
So there must be a main somewhere. Who is your main now? Python will now provide a main. It will wrap your module in such a way, because there is nothing else. You have not started Python shell. Okay, so that module now will become the main. So
okay,
if you do that, that module now becomes the main, and it executes whatever is there under the if statement.
okay, okay,
Okay.
okay.
Anything else? Okay, it's already late now. If you don't have any question, then we can stop this session today, and then we will have a totally different. It will not be elementary Python anymore, because I like to uh, discuss about elementary Python, but from tomorrow I don't think we will discuss Python anymore. Okay, we'll discuss a totally different thing. Okay. So far, whatever we discussed are very elegant, and because Python is very elegant. But from tomorrow, I don't think we will discuss something which is very Pythonic, I would say. It's not very Pythonic, but that does the job. Okay, for data science, whatever we have learned up to now is not very useful. Whatever we will learn tomorrow should be useful, and if you I can convey correctly, I think it will be very useful for you for the rest of the lectures and also the school. Okay, so see you tomorrow. I stopped recording and also